Yes. Yes, indeed. Hello, everybody. Welcome to SkyTour live stream for this wonderful evening. It is, of course, October 27th, 2022, and the sky is steadily advancing toward the winter sky. And you see, once you get through the fall, you want the winter to come so you can start looking at all those really cool objects. But before we look at any objects, let's welcome Daryl Mason to the stream. Hello, Daryl. How's it going?
Hello, Mark. I'm doing well, thanks. And you? Hello, everybody.
I'm doing fine, thanks.
Let me guess before you name what's on screen.
Okay. You can guess. You want to guess?
Oh, Albireo.
Yeah, of course. This is a beautiful double star we're seeing right here, Albireo. It's probably, to me, it's the most beautiful double star in the entire night sky. We'll zoom in on it a little bit. We're in night vision mode right now, but this is an orange K-type star. It's actually a giant. And this star here is a blue B-type star. Now, the O, B, A, F, G, K, M letter designations each have 10 designations within them. So you have a B0, 1, 2, 3, obviously to 9. Same thing with the Ks. So this is, I think, a K2 Roman numeral 3. The Roman numerals are called the luminosity class. And they're based on the type of evolutionary state the star is in. So the blue one is just fusing hydrogen into helium normally, and so it's a B8-5, Roman numeral V5. And this one I think is a K2 Roman numeral 3. I'll have to go check to be sure, but that means that it's a bright giant or a giant star. It's not a supergiant, but a giant. And these two stars are actually orbiting each other. It's a true orbit. And this, what we're looking at here, are stars that are, believe it or not, they are 5,000 astronomical units away from each other. Isn't that cool? Now, we know that, sorry, I'm just writing it for you here. We know that these stars, at the distance they are, we were able to calculate the separation. It's 5,000 astronomical units. That's 5,000 times 93 million miles, which of course is the distance from the Earth to the Sun. And that's cool.
I have a dumb question.
Yeah?
You were talking about the spectral types.
Yes.
You said a K giant, not a supergiant?
Yeah, I believe it's a K Roman numeral 3 giant.
Okay. My question is, can K stars even be supergiants? I mean, generally they're either blue or red supergiants.
Well, here's the thing. It depends on the snapshot of the universe we take, doesn't it? Because at a certain point, we're going to see a star that's maybe on its way to being a supergiant in this state. It's going to go through a giant stage. Like, in fact, when it goes up the asymptotic giant branch, the AGB branch it's called, it's going to grow bigger and bigger and bigger. And at one point in the snapshot that we have as a human lifetime, we'll see it in this moment in time where it's going to look like a giant star. Now, the spectrum could possibly tell us that it's an AGB star and it's going to get bigger. Okay, I do not know if this particular star, this primary here, it's called the primary, I don't know if this star is actually on its way up the AGB branch or if it's just now at the maximum size it's going to get, and now it's going to migrate and get smaller and so forth after possibly going into a red giant phase, or it's going to do a supernova thing. I'm not sure where it sits in its life frame, in its lifetime.
I guess I have something to look up already. I mean, a K star, it's cooler than our star, which is a G star.
Yes.
But still, it depends on its mass, I suppose,
right.
Whether it can turn into it.
Yeah.
Let me find out then.
All right. Let me while I'm sitting here, this is Albireo. Let me see what they say the spectral type is. Okay, they say it's a K3. Okay, a K3, number 3, 2. So the 2, 3, and Roman numeral 2, Roman numeral 3, Roman numeral 4, these are giant stars, right? So this is a K3, 2. So not a K0, 1, or 2, but a K3, Roman numeral 2. So it's a giant. it's a giant star. And depending on, as you point out, the mass, that will determine whether this star will eventually go supernova.
Okay, Albireo A is 5.2 solar masses.
Okay.
I didn't know there was an Albireo AC, so it's actually a triple star.
Yes.
AC, I guess, is secondary for the A component. It's also 2.7 solar masses. Mm-hmm. And Albireo B is 3.7 solar masses. So I suppose any... is that enough for 3.7 solar masses? Is that enough when it gets old it could turn into a supergiant?
Well, it depends where it is in its evolution now. I'm not sure, because the stars are going to go up the asymptotic giant branch at some point, and when they do, some that are more massive may end up going to supergiant status, but I don't know whether all of them are going to go in. I know that not all of them are going to go to, like, say, supernova stage, but they may not always get to supergiant stage.
Yeah.
So that's the curious thing.
If I had to guess, maybe the A component having over 5 solar masses, it might be the most likely to, at any rate.
Yeah, I haven't read any studies on Albireo to see what the story is with Albireo. I just love it. I just think it's the most beautiful.
Oh yeah, well, me
most
too.
Beautiful one, yeah.
Sure.
I want to say hi to Donald Kunzer. Ronald from ERRT Radio is here. Listen to Ronald's channel on Mixler, ERRT. And we have Genghis and Daisy and Zoe Amethyst. Albert Torcaso, hey, how you doing? Good to see you back. Izabela, hello, Izabela. How are you? It's good to see you.
Hi, Izabela.
Yeah. And then we have, I saw someone else out here that... Oh, yeah, PG. PG is with us. That's Petita from Pennsylvania. Pennsylvania. Hi, Petita, PG.
Long time no see.
I know. Where you been, Petita? Then this guy, Daryl, keeps going out there. Oh, and then we have Cosmic Ray. Hi there, Ray. How you doing? Nice to see you. And tonight we're going to have some fun. And Fantasy is with us. Fantasy next to see what's going on, man. Hope you're doing all right. And MPC is with us, MPC 305. Does MPC stand for non-player character? In this case, it's kind of a cool name if it did. And Mike C is here. Engage number 1. That's right. Okay, and D Smith is with us. Hey D, I haven't seen you in a long time. So nice to see you. Wow. And Hedrick's with us. Hedrick, you like double stars? Well, this is one of the most beautiful ones in the night sky. You know what? Here's what I'm going to do. Let's just do a stack on this just so you can see what it looks like, all right? I think this one's going to be pretty. Let's not do that, though. Let's get out of this. And let's clear this stack and start again. Start again.
Anything you could do to improve the color saturation on them?
Yeah, you actually have to take lower exposure so they don't saturate. And so by doing the stack, you can see the colors are a little better here. See that? Colors look nice. And we can do this. We can actually take our dark level in a little bit. Look at that. Now you can see those colors quite nicely.
Yeah.
Yeah. Unbelievable. Very nice. Yeah. Very cool. All right, let's see. Let me finish the hellos here. Okay, and I think that's it for those people so far. It says, oh, Ufi's here. Hey, Ufi, how you doing? Ufi Autori, nice to see you. Haven't seen you in a while either. It's nice to see earlier members showing up again. It's so nice. Yeah. Ronald, tell people what ERRT stands for as well. Bullwinkle 000's with us. How you doing? All right, let's. So this is, as I said, this is Albireo, the most beautiful double star in the night sky, in my view, and in a lot of people's view. And I will now save this. I'm gonna pause it, And you'll notice that Albireo is listed in the name up here already. That's because I already did one. I'll do it again. We'll save it. And then save it exactly as seen. Okay.
And Bonnie's here.
Hey, I know that. That's Anahata 77. I met Bonnie in person when I did a talk in Colorado. It was very, very nice. I really enjoyed meeting Bonnie in Colorado. Alright, let's do this. Let's go into night vision mode now. Alright, and we're running at a gain of only 100 right now. So what we're going to do is we're going to up our gain so our sensitivity is much, much higher. The period that the stars orbit around each other is, I think, a few thousand years. I'll just have to, that's another one to look up.
Yeah. Let me see if I still have that open. No, I don't. I'll open it all over again.
All right. All right, let me set the gain. The two things you care about over here is the exposure time and the gain. The exposure time, like the time that the sensor is receiving light, and the gain is how sensitive the sensor is to that light. All right. So we'll just take this up a notch now. Notice how many more stars show up when we do this? See that? It's incredible. So we're going to go right to 400. Look at all those stars now. Telling you, it's a whole new world. Pull that out. All right. So we're up in Cygnus because Albireo is actually the eye of Cygnus the Swan. And here is the swan right here. All right, and there's the eye. And we're going to move right up into Cygnus here. We did the Veil Nebula, which is over here, the other night. We're not going to do that tonight. But what we'll do now is head to other locations that are cool. Like, we can just zip up to the Cygnus star cloud here. And I'm going to move us manually because it's just so much easier. Actually, do it this way. So I get more out of it. What?
I thought they were physically associated. They're not necessarily so.
Well, they're orbiting each other.
Well, not according to Wikipedia. They don't know whether the two are orbiting each other, or if they're merely an optical.
They got a period of orbital period though.
That's Wikipedia for you.
Wikipedia is sometimes not accurate.
Yeah. Still looking for the orbital period, if there is one. And I misspoke. The K star is the primary star.
Yes.
And it has a secondary.
Yeah.
And then Albireo B is actually the hotter star.
All right.
It's a B8, and Albireo A is a K2.
Okay.
Albireo AC is actually a B star also.
Yeah, it's a very hot region of space, let me tell you. Sorry, guys, I'm just trying to get my slewing speed set. I just want to go to this guy right here because there is an object up here that I want to check out that you'll like to see too. All right, and there it is. I believe that's the Tulip Nebula. I could be wrong. Yeah, I think that's it. I think that's it. So if we actually center on our telescope view, then this, if you look where the writing is, if you turn your head so the writing is upright, then the tulip is going to be just about here. And when we come in here, it is just about here. So there it is. So let's actually go check this out. I think I'd like to see the Tulip Nebula. We're going to head east a little bit, though.
Albireo's period, it says, is 121.65 years, but it looks like that's actually between AA and AC.
Okay. Yeah, the 5,000 that would be really fast speed, you know, if you're the primary and the main secondary. Okay. All right, we're going to center up the Tulip Nebula. Let's make sure we got it. And just about. And we're going to bring the telescope south just a jiggle. It won't matter. There we go. Then we can turn off our crosshairs. Okay. Now, let's do this for... we'll let it stabilize. Let's... first thing I'll do is go in and get set up on the guider rates so that I can make sure they're all working. Okay, see we're guiding now. You can see the numbers changing right there. That tells you we're guiding right now, and that's good. So, this, I believe, is the Tulip Nebula, isn't it? I think that's it. And we're going to try a 30-second exposure of the Tulip Nebula. Telescope, if you notice, is just almost straight up. It's looking a little bit to the west. All right. And we'll do 30 seconds. And away we go. And then we'll do a live stack on this. And we'll clear it. You see down there in the lower right corner, you see the progress bar down here that tells you how far along we are. This is our data screen where we look at the data. Hey Greg O'Brien, how you doing? We just looked at Albireo, and now we're heading to the Tulip Nebula. Okay, here we go. Oh, okay, well, we have to adjust it because our curves are way off the data, so obviously it looks black. To those on large screens, sorry I blew you out, but now it looks better. Check it out. Look at that. Wow. Okay, we're gonna explore this one for a while. You know, I've said this before, but I gotta tell you, the universe is my cathedral. It is my cathedral. Cindy Murphy, welcome to the universe of the Universal Cathedral. Looks something else to me. Let's go down here. Yeah, let's do a color correction to help pull out some of the data. Oh, wow. Look at that. You can see some of this beautiful stuff. This is gorgeous. Wow.
I think I'm having a brain cloud tonight. I thought you said Iris Nebula. This is Tulip Nebula?
Yes.
Okay, never mind.
Yeah. No, that's okay. That's okay.
I was thinking that doesn't look anything like the one we looked at the other night.
Oh, I know that. That is not a cloud. That is a giant swan's body. Okay. And I think what we'll do is we'll bring in some of the other deep sky objects. We'll bring in the Caldwell catalog. We'll bring in the Barnard Dark Nebula catalog. We'll bring in Sharpless 2 catalog. And we'll bring in Lynn's Bright Nebulae and Lynn's Dark Nebulae. That'll be more than we can handle because it's going to clog up our screen, as you'll see. And this is what's known as a Cygnus star cloud. This is what this is right here. But it's also called the Tulip Nebula, as you can see. And it's a Sharpless object. Sharpless 2 101, as you can see right there. But who cares about Stellarium? Let's go look at the real life thing from right now. Greg O'Brien says, Mark, can we look at Jupiter? We could, Greg, and maybe we will. The only problem with it is that this is a wide field telescope, and with the second telescope that we add to the building, that we're gonna get, that second telescope will be able to more adequately look at Jupiter, and you'll see cloud bands and details on the cloud bands of Jupiter, and you'll be able to see Saturn really nicely and the moon exceptionally well. So it's adding a ton of capability to SkyTour Livestream. So that's something that we will be doing, and that will be fairly soon.
If we look at Jupiter with this telescope, it'll be, oh, you can see the body of the planet. It won't show much detail. And we could see the 4 Galilean moons going around it. That'll be about all you can see.
Yeah, this telescope is designed for wide field views, looking at vast swaths of sky. And as a matter of fact, what you're looking at here, when we zoom out, okay, all right, here is the entire field of our sensor that we're looking at here. It's 4 full moons across, okay, just about 2 degrees, and it's 3 full moons tall, so 1.5 degrees. So this is something else. This is what we use for looking at these faint and dark nebulas. It's just beautiful. Yep. All right. Okay, we have stacked 8 of these, and we need some more. When we do the higher gain, we need to stack more so that we can get rid of some of the noise automatically. But as you can see, it's looking really pretty. Look at that. This is the depths of this Tulip Nebula as we zoom in.
Well, it is nice.
Yes. All right, and
I haven't seen you run a focus lately.
I did it before we started, but
Okay.
I'll do it as well. Tim F, woohoo! Nice to see you. Albert, thank you for subscribing. I think that's great. Ronald will love it. All right, we'll back out here. Let's go into our stack and do a little maintenance. Let's try color correction. Should not change too much. All right, that looks right. That's pretty. All the red is this ionized hydrogen regions that are ionized by hot stars nearby. Within this nebula here, these stars may be the ones that are causing the gas in here to be ionized. It could be this star over here. It could be a star inside this dark nebula that we don't see. This is not a void in the stars. This is actually a dark nebula that's obscuring the stars behind them. All this patchiness you see is because this is dark dust in front of a star cloud, and it's actually obscuring the stars behind it. One of the things we can notice when we look at these deep nebulae is for stars that are inside the nebulae. You notice if this is inside the nebulae, notice how they're red. You see how many red stars there are here? There's an inordinate amount of them. Well, the red color that we see, not that's actually an artifact of the camera on this particular exposure. These red stars in here are possibly stars that have white light, okay, like our sun, okay, but because they're in the nebula, the dust inside the nebula is scattering the blue light coming from those stars, making them look redder, in the same way the sunset is red. But there are red stars that are really small and really tiny and low luminosity, low brightness, intrinsic brightness, and that's what we're possibly seeing as well. You'd have to study each one to see, is it in the dust or is it a class M, spectral class M star. It could be both a spectral class M, and it could be a spectral class M and be inside the nebula. I see Daisy and Zoe had a problem with the stream, but the stream is going fine. We have greens at this end. Okay. It's okay now. They restarted the stream. Good. Yeah, sometimes that happens. I don't get it. You like my universe background, by the way, guys? I'm a Milky Way boy. I'm bathed in the light of ionized hydrogen tonight. Wow, look at that. This is 16 stacked images. They're starting to look really pretty. And the guiding, of course, for 30 seconds is literally as close to perfect as we can get. Very happy with this. As I said, when Tara Diulis and Marianne Robb went out and put the telescope back in with Dale, Tara's husband, they took the time, with my instruction to balance the telescope properly, so that when they let go of it, when it's all unclamped, the tube doesn't want to fall, the tube doesn't want to flip back, the tube just stays there. Wherever you rotate it, the telescope would stay there. And that gives us a balanced telescope, meaning that the guider has to do less work. And when it has to do less work, it can be more accurate. And as you can see, oh, it's pretty. I think we've seen the Tulip before, but this looks pretty good.
It's very nice.
Cosmic Ray says, the two stars making up Albireo are not physically associated. It's a visual double, not a binary. I'm not sure of that, Ray, because if you're looking at Wikipedia, I don't think Wikipedia is correct on this.
Well, yeah, that's what I tried to differentiate earlier. The two components of the brighter K star, the A segment, they are orbiting each other with a period of about 121 years, I think it was.
You can't even see those.
Right. But then, it's maybe the A and the B components are not associated.
Possibly, but I'm trying to remember. I didn't just make up the factoids. I read this paper that talked about Albireo, and I thought that it said that they were definitely orbiting each other, and they gave a period, and they gave a separation between them. So, I mean, there's plenty of line of sight binaries out there. So, by the way, as of today, Elon Musk now owns Twitter.
Did you see him carrying the sink when he went in the other day?
Everything but the kitchen sink, that kind of thing?
Yeah, I guess that was the idea, but it looked more like a bathroom sink to me.
Oh, that's funny. Well, look, you know what? I don't care. I mean, we don't do politics here at all. We just do science, and it's going to be easier for everybody to do science with Twitter having a more stable playing field, because people ban other people just because of their thought processes rather than what they have for it's adding value or not. Hey, Farva. That's Sean is here. Hey, Sean. Greg says, Mark, I was just talking with Tim Seymour. Who's Tim Seymour? I do not know that name. Tell us who he is, Greg. Okay. I'm telling Marianne we're streaming. Okay, we did 25 on the Tulip. Look at that. Let's go back and look at what it looks like overall. Oh. Oh, Greg says Project Starlight. Okay. Thanks, Sean. Thank you so much. All right. So we are at 26. We'll go to 27, and then we'll go to the next object. There we go. And this will be the Tulip Nebula. Yay, the tulip. I like the tulip. And we'll save the astronomical fits format. Hey, Xanarak. And we'll save exactly as seen. Alright. And now let's see. Alright. That's good. So now what we'll do is we've saved it as seen. We can get rid of it. We'll flush it from the buffer when we start the next one. All right, let's go into our night vision and take us to the next object here. So we're sticking around Cygnus right now, and right near here, let's pull out a little bit, is another object we want to check out. This is another location in Cygnus that is absolutely full of amazing features. This object we're going to right now is a location that you don't want to be anywhere near if it goes off, and it will someday. So we'll just do a high precision guide to it, and then once it stops and gets to its place, we'll check it out. This is called the Crescent Nebula. The Crescent Nebula is absolutely, I'd have to say, one of the most bizarre places in the universe. This star here, where we're centering on, is called Sadr. That's S-A-D-R. And then it's taken us down to the Crescent Nebula. Alright. Here we go. Alrighty, so now we're gonna pull ourselves up into that region. Doesn't take much. This takes going a little bit north, and we'll see the Crescent Nebula right there coming in, and you can see why it's called the Crescent right there. So let's talk about the Crescent Nebula. The Crescent Nebula is really quite an amazing location, because this star inside here that caused this nebula is exceedingly hot, and it's a very strange star. It's called a Wolf-Rayet star, and it has a interesting history, and the Wolf-Rayet stars in general are very, very, very dynamic. Very, very powerful stellar winds that blow off so brightly and so with such radiation pressure that the outer layers of the star are literally blown off the star by the hot core that's producing so much energy. So this is actually is amazing, because once we'll do this stabilize. Once we do an image of this, you'll see all the detail in here. And the interesting thing about this star, which is the Wolf-Rayet star, is that it's not done yet. It's eventually going to explode in a major supernova. Most of the Wolf-Rayet stars, if not all, are going to do this. So let's go stack it, and we're going to clear the previous one. This one's up on the database already for you to go check out if you want. And we'll clear this because we've already looked at it. And let's go check out the Crescent Nebula, the Wolf-Rayet star that will create a massive supernova sometime in the future. Yeah, the witch head is not up yet, that's correct. All right, here comes the crescent. Ah, look at that. That looks stunning. That's a 30-second shot, guys. That's really impressive for just 30 seconds. You see all these other faint nebulous detail, because we are in the Cygnus star cloud right now, the Cygnus Milky Way. Yeah, we'll zoom in a little bit, and then we'll come back out later. You can watch these filaments develop as we get more and more detail coming in. Wow. If you have any questions, please put them in the chat. We'll be happy to answer them. And don't worry, we'll see the Witchhead Nebula in the next couple months, I'm sure.
Yeah, Orion's up before midnight now, but we have to give it time to clear the observatory wall.
Yeah, because the observatory wall is, you think, well, the walls, why the walls? Because you don't want to look right to the horizon, because things will look crappy. Because you're looking through a lot of air. Marianne's here. Shh, don't tell her I saw her. And so we have to wait for the objects to clear at least 40 degrees, 35 degrees above the horizon. And then we'd be able to see with more detail and a lot better. Hi, Marianne. It looks like an amoeba, Daisy and Zoe Amethyst say. It kind of does, doesn't it? This is a universal amoeba. Well, what do you call it? A space amoeba. A spamoeba.
Antibodies.
Antibodies, yeah. Well, it could also be a virus. The human race is a virus.
I don't do a very good James Kirk impression, sorry. You know what I'm talking about.
The Star Trek episode.
Yeah.
Yeah. Antibodies. Look at these gorgeous filaments. This is always interesting to me. This one little arc that we see in here. It almost looks like, if we zoom in on that a little more, it almost looks like, and obviously we can't go in too far right now, but it almost looks like this arc is caused by a shock front where material coming from the star has hit interstellar material and ionized some of it. That's a possibility. Really pretty. Really pretty. Ginga says a fire opal. Yeah.
I have another dumb question. First, again, the star here inside is another Wolf-Rayet star, correct?
Yes.
Okay. If Betelgeuse is a good supernova candidate, could Betelgeuse become a Wolf-Rayet star before it goes supernova? What's the difference?
The difference is that the Wolf-Rayet star is really a hot core. Right now, most of the envelope is already gone. All right. Betelgeuse is a supergiant where its envelope is still there but distended, and it's sloughing off material on the outside. But it's not in this state. This star is the strange in-between state for stars of high mass. And they don't follow the same rules as stars like Betelgeuse, unfortunately, which is cool.
Okay, thank you.
Yeah. Hedrick says, do we know the distance across the colored border of the nebula? I don't know the distance that is currently, like, from here to the star. I don't know that distance. Remember, we're seeing things in 3D, so we don't know if this is coming at us or going away from us, which would make this a wrong distance no matter what. We'd actually have to get... The only way this would be right is if it's heading out directly away from the star in, at the same plane as the image here, the image plane. But we could estimate the size based on going from here to here. I mean, this could be like a thing that's going like this to us. Or if it's not like this, then it might be like that or like this. We don't know. or it could be, like, it's going to be this football type object shaped by the interstellar medium around it. I do find it interesting, though, when you look at this side and then look at this side. There is a focus of hydrogen gas here and here, and there's oxygen that's being ionized here and here. Now there's hydrogen throughout and oxygen throughout, but the hydrogen is dominant here and here, and it's a little bit here too. So something in the way this star ejected those layers leads to this topology, the way it looks in the sky. So I think that's pretty interesting how the genesis of these things must happen. And we don't know enough about Wolf-Rayet stars to even know when to expect their end state. We think that they're going to go supernova. So it is what it is, you know. We stacked 12 of these. This is looking pretty. Let's zoom out, as I promised, and look at the whole field for a minute. Okay, well, there's the whole field. 4 full moons across, 3 full moons tall. And look at the colors. Is this not beautiful? The colors of the universe are just staggeringly gorgeous. Let me just do the... There we go. Wow. And the designation for Wolf-Rayet stars are WR. So this is a WR star. I'll put that in for you to see. And so you see what Wolf-Rayet looks like too. Okay, let's put that out there. So that's a WR star. Oh, here we go again. You know you're somebody when the porn messages come out. Okay, you're gone. I guess when you get a certain number of subscribers, that starts to happen. We're almost at 7,400 subscribers, guys. This is crazy good. Thank you. Please subscribe. You know, the more you get, the more people that subscribe, the better it is for us, and we'll be able to do things once we actually can start making a little money on the channel. We put all the money. All the money goes right back into SkyTour Livestream. I don't do anything with this money that we make. Not from the GoFundMe, nothing. That stuff just goes right back into this. Thank you, Fantasy. Fantasy knocked somebody out. You can just hide them from the channel if you've got that choice. Wish you could remove people. I don't know. Okay. Alright, we're at 18 stacked here. We'll go to 20. And then we'll move on. Because it's only 11 o'clock. And I'm an astronomer who wants to see the stars. We do have an issue, and I'll point it out to you in just a minute. I'll show you here, actually. We do have what looks like a beautiful sky. There's our Milky Way. Let's make this a little bigger. This is our all-sky cam that I brought up. Alright, you can see it's gorgeous, but we do have some clouds down here. We have some clouds here. Let's do another acquisition and hope that we haven't confused the camera, because it does confuse the camera sometimes. Let's pull that out for now. When I'm running all this other stuff here, it sometimes confuses this all-sky camera. So let's make sure that okay, good. Hey, there we go. It looks like we're okay right now. This here, I've told you before, this right here, this is the light dome of Phoenix, which is like 70 miles away. To the sensitive camera, you see it. But to the all-sky camera, you know, you can see when there's clouds, you'll see clouds look dark against the sky rather than bright clouds. The only way they look bright is when they're looking toward Phoenix. There's Jupiter right there. And this is Saturn, I think, right there, isn't it?
That's Fomalhaut.
Is that Fomalhaut? Where's Saturn then?
The one farther to the left.
Even further than Fomalhaut? Or is it this
Yes.
one?
No, okay. You're right. That's Fomalhaut, and then that's Saturn.
So this was Saturn.
Yes.
Okay.
The orientation throws me every time.
I know. You like south on the bottom. So do I. And when I go out there, what that means is I've got to literally take the unit apart and flip around the camera, because I can't just reverse this image in the software. At least not that I could find. There has to be a way to do that, though. I just want to roll it. And I think there might be a way to do that in the settings. I'm not going to go do it now, though. All right, good. So we still have good clear skies. All right. I said we stop at 20, but we'll just do this one and go to 24. Let's see what we're looking like. Let me come and zoom in here. Well, it looks pretty good. There's so many stars that it almost looks like they don't belong there. Just beautiful. Okay. So there's 24. So we're going to pause this now. And we will save this. It's on its way up as of now. It's going right up to our online repository, which you have full access to just by going to skytourlive.com right here. Okay, see Skytour Live? You go there and you'll get access to everything you see here, because we do not take any money for it. It's all free. Now if you want to print, well, we make hyper processed beautiful prints for you, and we'll take an image like this, bring out as much detail as we can, and then make that a print that's available. We're also there's another thing we're starting as well. If you want to see and take down to print yourselves the best of the best images we have, then we do have a process we're starting, sort of like a Patreon. We might even do it through a Patreon, where if you're a member, you can go to that special directory and download anything you want, and they'll change regularly as we add more to it. And then you'll have access to every previous, beautiful image. Because these look pretty, but when you actually do processing on them, you can actually pull out details that we don't even see yet. It's amazing. So I think that was, I think that's pretty amazing. So that's something we're starting really soon. Kinga says, nearly overwhelming amount of objects. Yeah, absolutely. Tim F., we have SkyTour t-shirts. In fact, we're going to start offering them as well. We have SkyTour mugs. All that stuff is also what we're going to offer, all of that. Because it's very important, I think, to give something back to the SkyTour family, right? All right. So here we go. All right, so now Fantasy says, if money was no object, what else can we do at the site of the observatory? Okay. I have a spectroscope system here that I'd like to add to another telescope, and do that. Well, Ronald, you get a free one because you gave me a mug for your ERT radio. Ronald says, I want a t-shirt and a mug. Yeah. So
I want an Astronomers Love Heavenly Bodies t-shirt.
Well, that we don't make. You can just get that on the that science t-shirt site. All right. And that's a great shirt, though. All right. We're going to get out of this guy. This is, again, the Crescent Nebula, a Wolf-Rayet star. And it is, by far, one of the more violent places you'd ever be in the universe, other than the event horizon of a black hole. Okay. I think I have a better one, okay, and that is never trust an atom. They make up everything. Ah. I actually own that shirt. Never trust an atom. Alright. Let's go to night vision mode now. And let's go find the next item we want to go to. Gee. I wonder if we should go. Should we go check out this part of the Gamma Cygni Nebula?
I think that's why they put it in Stellarium like that.
I think we also had the lobster claw, right? Isn't that this? Is that not where this is? I believe that is it. Let's check out that part of it. We can always come back. We're going to just go to this spot in the sky. Before I do that, though, let's bring our computer back up. And now, we're going right here. All right. And it's going to take us probably to Satyr right here. Yep, it is. It took us to Satyr right there. And that's going to be our waypoint star. This region is so full of nebulae that it's just beautiful. The lobster claw, I believe, is what we're going to see now. Is that not... This is the lobster claw, right? Oh no, I'm wrong. The lobster claw is below the bubble. This is actually the bottom, or I should say, the northern element of the nebula, of the Gamma Cygni Nebula. Right. So let's go up and check that out.
Northern.
Yeah, I said northern end, yeah.
Can you back out and Stellarium a bit?
Yeah, just a minute.
So I can get my bearings.
Yeah. We're heading toward the North America Nebula.
Okay.
But I'll back up.
So Denotive is up at the top right?
Or, yes, that's it right there.
Yes, okay. I know where I am.
Alright. See all those designations, guys? That's all the things that are up here. I went a little too far. Or did I? No, I didn't. I went perfectly to where I wanted to, and then I lost my own bearings. We should just do this. We're going to do that. Center it up on that guy. So now I know what to do. Alright, let's see here. Ready? Alright, and then we just go north a little more. And catch the top of that nebula. There we are. This section of the nebula is actually really cool, so that's why I wanted to look at it. And look, you can barely see it. But that's going to change. We'll do another 30 seconds here. Alright, now let's let this stabilize. Looks like we are doing alright. So away we go. Into the live stack. We should be ready to clear this. You think there's a lot of stars here. This is going to be another one, but it's also going to have lots and lots of beautiful red nebula in it. What is Izabela? What are you trying to say? I want a TND, a hat.
She wants a t-shirt and a hat.
Oh, T and a hat. Okay. Thank you for translating. All right, let's this I want to show you down here. This area of the nebula. Okay, we're just a little bit not quite south enough. I'm gonna take us out of here, and just to go do that, I want to bring us back to get us where we have to be, and it's not quite where I want to be. Back to this. Alright. Uh-oh. Oh, wait. I thought it was clouds, but it's not clouds. It can't be clouds. I just didn't hit the right thing. Here we go. No, didn't do it right. Yeah, it did. There we go. Okay. Alright, so now we just go south a little bit. There's two beautiful little reflection nebulae sitting amid the wonderful nebula in here, this beautiful emission nebula. Okay. Hello, Robin. How are you? Robin says, I heard Fantasy's questions about the money or no object, what we would do. I didn't hear the answer. You know why? Because I didn't fully answer it, I don't think. I would like to add a telescope that would, in addition, have the ability to do spectroscopic analysis. Spectroscopes are hugely expensive. I've got one behind me that I want to do out here. What they would allow us to do is look at these stars and literally pick apart their chemical composition and show you what's hiding inside of them. It's also possible that with a higher quality spectroscope, we'd be able to determine when a planet passed in front of the star, polluting the spectrum a little bit. That's, of course, highly dependent on your aperture as well, and so we would need a bigger scope for that. Probably a whole new building. Okay, this...
You mentioned a solar telescope the other night.
Yeah, that I see happening for this telescope, this observatory. I'm talking about another building even to handle a bigger research system, yeah. I want a family of observatories all around the country. You know, that'd be the best. Actually, around the world. If anyone's in Australia who has excellent property way out in the middle of nowhere, let me know if you want an arrangement, because maybe that's a way to actually do a southern observatory as well. I'd love to look at the tarantula. I'd love to see the Magellanic Clouds. Imagine a hyperstar telescope down there. Whew.
Oh, yeah.
Okay, we are going to go now to 30 seconds here to show these beautiful little reflection nebulae hiding inside the emission nebula. Here we go. And to be clear, we're going to show these are now going to be right about here, so you can see this beautiful color difference.
Cool.
Right? Yeah. So
that looks vaguely familiar.
Yeah, we looked at it. We've looked at these. And where they are is it's these two guys right here.
Yeah. Did you get your pointing fixed?
Not yet. I'm working on it. I've got some support that I'm working on. Look at this. Wow. Isn't that beautiful? That is just beautiful. So these stars right here, it's interesting you see like a pair of stars and a pair of stars, but these two stars are shining their light into dust clouds, and the dust clouds are scattering the blue light from the star, which is why you see it as blue. Again, it's called Rayleigh scattering. It's the same type of scattering that produces our blue sky. Except in our sky, the dust particles and the atoms of nitrogen and oxygen in our atmosphere will also scatter the blue light, because blue light scatters very easily. So it doesn't have to be just dust. But dust is also very efficient at doing the same thing. That's just something. I don't know what it is. Maybe it's the stark image of the blue nebula against the dark nebula here that just does it. But man, this is really pretty. Look at that.
It is.
And again, we're doing this at 400 gain. C&D boy, how you doing? Good to see you. And you say that I like to see the American Meteor Society calendar of meteor showers, and Heavens Above page is also good. Yeah, that's true. Heavens Above is a great place to go to see historically what was passing overhead, what will be passing overhead. Yeah.
Heavens Above is usually my first stop.
Yeah.
And if I want to look closer, then I go to Spheriá.
Hedrick has a question.
Space weather's good too.
Yes.
I saw there or somewhere in just the last day they're saying, and I meant to mention this to Bill, New York Skywatcher too, that there may be quite a Taurus meteor shower this year.
Okay.
I need to go find that. Anyway, Hedrick has a question.
I know, I just said that.
Yes, I was apologizing for interrupting.
Oh, no, there's no apology needed.
Apology accepted, Admiral.
That's right. Apology. Wait, let me do it right.
Apology accepted, Admiral.
There, right?
I knew you were going to do that.
That's the Vader bottle. I mean, it even says so on it. Look, it says Vader bottle. It's like,
you are part of a rebel alliance and a traitor. Take her away.
I've had that bottle since 1977. Okay. Hedrick says, what are you expecting to be the next big events in astronomy? Oh, my goodness, Hedrick, that's a really good question. Most of them are going to be centered around the James Webb Space Telescope. As you know, the James Webb sees things in the infrared, but it sees things way far out in the infrared, much farther than the Hubble Space Telescope can go. Okay, which is just incredible. And so, when a galaxy is far, far away from us, it's speeding away from us faster than galaxies that are closer to us. This is called the cosmological redshift. Daryl's mentioned it, I talk about it. And as it does so, its light is being shifted farther toward the red. That's what redshift is. In sound, it works this way. When a car is approaching with its horn going here, and when it gets past you, it goes,
a Doppler shift.
That's a Doppler shift. That's a Doppler shift with sound. Well, light gets Doppler shifted too, but it's not sound, it's light frequency, and that translates to color. So the light coming toward us will be bluer when it's coming toward us, but then as it's going away from us, it'll look redder. That concept has nothing to do with what you're seeing here. This is truly blue light, no matter where you are in the universe, and seeing it, it'll be blue. Okay, and so, where you are in the galaxy, I should say. And then when you look at a galaxy speeding away from us, again, the ones that are farther away have a higher redshift. So you can imagine a point where all that light data, all the galaxy's light that's emanating is shifted all the way off the scale that you can't see. See my hand? You can't see it out there. Comes back in. This is where we can see to. And that's just about where the Hubble could see, a little farther. But then the James Webb is seeing even further out by a long shot. And by seeing way out there into this distant red end of the spectrum, we're actually seeing galaxies we have never ever seen before, in details we have never ever seen at all.
Yeah.
So that's the beauty, and that is going to be the big thing, I believe, with the next big discoveries in astronomy. It's going to come from the James Webb Space Telescope.
When you see that early James Webb image of the supercluster and all, it was kind of comparable to the Hubble Deep Field, though it was a different field. The Webb field was showing us things so far away, as Mark just said, that the Hubble couldn't see them. And because light was redshifted completely out of visible spectra. And the Webb was detecting them with infrared telescope and bringing them into visibility for us.
Yeah.
They were so far away that Hubble couldn't see them anymore. They were redshifted clean out of visibility.
Yeah. And they went past the Hubble's ability, as Daryl just said. Now, as far as any new events in our solar system, well, that docket isn't empty either. There's plenty of amazing finds yet to be found. In fact, there is one microbe that they think they've identified as a very, very hardy survivor that might be able to exist underneath Mars. And so they're targeting, looking for this microbe in the Martian soil beneath the surface where the ultraviolet radiation doesn't get to. So that's going to be pretty cool. That might be found by the InSight lander, possibly, and maybe Perseverance, but I'm not sure. Perseverance is, working around the surface and stuff. So that the Martian dilemma is the one that is going to be the find of the century, when they find that there might be life underneath, say, the South Pole of Mars, where there's a subterranean reservoir that's been found. It's like about 1 kilometer down, and it's about 12 kilometers long. Because down underneath the surface, where the pressure of the overlying strata can keep water liquid, there is liquid down there. There's water. Now, so, water is very important to find. We see it all over the solar system, okay? And speaking of water, the other big find will be on the moon of Jupiter called Europa. Europa is 1,920 miles across, just about the size of the moon, a little smaller. Yet its surface is covered in an icy mantle. But beneath that surface, the pull of Jupiter and all the other moons have been kneading it like dough for billions of years. And that's kept the interior warm. And it's also caused the water underneath to be melted. And it may be that there's life below that icy mantle. Now, it wouldn't be able to use the light of the sun for energy. It would probably have to be chemical, like chemosynthesis. So I think that is something that we have to think about. So we got the Europa Clipper and another Europa mission on the docket to go and check that out.
The first thing I thought of when I heard that recent Martian microbe story was, you remember the meteorite they found in Antarctica back in the 90s?
Yes.
ALH 840001 or something like that.
Yeah.
And that was the first thing I thought of when I heard that.
Yeah. I mean, that meteorite that was found in the Antarctic ice sheet was displaying some oddities that look like fossilized bacteria. Now, they said, well, it's been in the ice sheet for so long that maybe it could be contaminated earth residue inside this meteor, and that's possible. But the thing about the Antarctic ice sheet is that when meteors hit there, well, they're only falling at their terminal velocity when these little ones hit, because they've already come into the atmosphere, slowed way down, burned up, and now they just fall out of the sky. They don't strike at 50,000 miles an hour. If they hit you on the head, it would hurt, but you would say, ow, Now, if they're really big, then they could, of course, maintain that kinetic energy, all right, and kinetically go through your head. But in general, when they're small little nodules, little rocks, they'll fall out of the sky and just land at the normal falling speed from that height. And just to give you an idea what that is, they did an experiment with the Empire State Building. Remember the old myth, and it is a myth, that if you drop a penny from the Empire State Building, it would kill somebody if it hit them? Well, the truth is, it wouldn't. They actually took a helicopter with like 10,000 pennies and poured them on a guy from the top of the Empire State Building height, and he was wearing a little helmet Okay, and where they hit him, it stung, but it didn't even penetrate his skin. So that myth was busted, and it had to do with the fact that the penny can only fall to us at a certain rate. Same with a space rock, you know, depending on its size and mass.
They did that on Mythbusters too.
Did they?
They did. If I remember right, you know, it's what a penny's terminal velocity is basically, which was, I want to say it was like 63 miles an hour.
Yeah, and it couldn't go through anyone's head. It couldn't kill them. It's just a, you know, interesting experiment, right? All right, this is where we are is NGC 6914. At least that's the region we're in, so I'm not sure, but that's this. And we're at 25 stacked. That's good. We need it with the 400. Okay. Let's see. Here we are. All right. Okay.
Excuse me a moment, please.
Yeah. All right, just 1 second, guys. I'm just trying to get the word out. Here's the word, and the word is good. NGC 6914 emission and reflection nebulae here in this picture. All right. We did 26. We'll let it go to 27, and then we'll stop. And there's 27. So we're going to pause. We're going to save because I've got it written up there. Okay, and now we will save exactly as seen. Isn't that pretty? There's going to be an awful lot of really beautiful detail to pull out of that as well. My gosh, really pretty. There's the tiniest bit of wind out there, but it'll be okay. All right, so we come up here. Back to 1 second. And go into night vision mode, and then we can zoom out. This is already on its way up to the server, so you'll see it there in probably 3 minutes. I hope you guys actually use the server. I think that's pretty cool. Hey Prow, how you doing? Izabela asks if I processed the Veil mosaic. No, I've actually had to build a submarine model for the Navy, so I've been doing that. And then next week, I go to Arizona to teach astronomy out in the desert. And then, thank you, Sean. Sean, we're not doing that. It's the spam bots that get us, so we have nothing to do with it. We actually remove them as soon as we see them. Oh, that stupid sites, the adult sites. I would advise you not to go to them though, because once you get in there, I'm gonna guess that you're probably gonna get spammed away with viruses and so forth. Okay. Now, yeah, go ahead.
I just laughed. Sorry.
Oh, okay. All right. Let's keep going north.
That reminded me of something.
What's that?
I had an old email address that got hacked a long time ago.
Yeah.
And some site like what you were talking about had been using my email address.
Oh.
And this old address I didn't use anymore.
Okay.
And I actually got a reply once. Some guy from Germany was very interested in what they were offering. Yeah, I'll just leave it at that. It was all pretty raunchy.
That's funny. That's okay, Sean. Okay, so Deneb was the star used for the waypoint star, and from there we're going to go to the North American Nebula. We've actually never photographed North American Nebula with this amount of gain on the camera. So it's going to be interesting to see how it turns out. That's the wall right there, you can see.
Yep.
And we're going to go north a little bit. The wall is it's the edge of a molecular cloud where this dust and gas meet, and really it's a very, very relatively dense area. Okay. All right, we're going to...
Already looks like it's happy to see us.
No wonder those spam bots are going after us.
Yeah.
Alright. So we're going to bring in the entire North American Nebula. I'll keep the wall in there. And the top of the nebula will go out. And then I'll move over to catch the Pelican, which is to the west of us. Alright. And so as we move over, you'll see another nebula coming in. Which is right here. This is the Pelican. This is the eye of the Pelican. You'll see it in just a sec. Yeah. That's pretty. Now with the new telescope, we might focus only on one section of the North American Nebula. It'll be just really, really nice. Okay. We're going to stabilize. Let us get our guide star. It takes about 14 seconds to get the guide star. And from there, we can just start guiding once we stabilize. So we let the guider stabilize and do an averaged result, which is doing fine right now. So now we can actually come down and do our 30-second shots now in the live stack. And there we have our previous beautiful 6914 NGC 6914 reflection and emission nebula. That's really pretty in there. This is the last picture we took, but look at this.
Did you name it?
Yeah, NGC 6914.
I can't read the...
Oh, that's the other one. Okay, what I'm going to do is get rid of this now because we're doing the North American Nebula. Right, and I already named it North American Nebula. Ah, look at that. Wow. This higher gain is going to allow us to see some of the details in the dark nebula that we have not seen before.
You know, if you wanted to recompose your shot, you might jog it down, or actually I guess telescope go up just a little bit and to the left a little bit.
Just to get the backside of the Pelican?
Yes.
Yeah. I just didn't want to lose this part of the wall over here.
Yeah. Just a hair.
Well, then why don't we'll do this, and then
do a mosaic.
There you go.
All right.
Yeah. So we'll do this and go for a certain number. We won't do 25, but we'll get to a certain number, and then we'll do the second half. So this will be North American Nebula 1-1. Okay. Yeah, Izabela, thank you for putting that up there. We'll let you know when the new telescope's coming, Izabela. She says, oh, can't wait for the new scope. Me either. I will be making a special trip out there to do the installation, too. I'm not going to rely on anyone to do it because it's a brand new scope. We still have to have the pier made. Okay, that's going to be Marianne Robb is probably going to oversee that. And then I'll be out there to install the new computer that's going to run it, and the system that's going to, all the software that's going to be on there. It'll be very much like this. It won't look any different to you than what we're seeing here. And when we run that, when we get that running, you'll see that the field is going to be very different. I have to calculate the field. I'm not sure what the field size is. But I think this area might be what we'll see. And it'll necessarily be better because even though we can zoom in to good effect here, we're already going to be at this level when we start, and we can zoom in twice as far as we can now and see tremendous detail. What am I going to do with you?
I don't know.
Right.
Look at the tendrils and the shapes in the dark nebulas.
Yeah, like here, look at this.
It's really something.
It's really pretty. What I haven't done yet, which I'll do now, is I'm going to add the masking, what's called the unsharp mask. So watch the detail just skyrocket. Ready? Here we go. Look at that. Look how much more detail is visible now. Can you guys see the difference? I'll show you. Let's zoom in on what's called the Cygnus wall right here. Okay. See how this looks sharp and clear, right? Watch what happens when I remove that masking. Ready? Here it comes. Now it's off. Look at the difference. Now let's add the detail maker, which is the unsharp mask. There it is. And
Seems to have brought up the red quite a bit.
Yeah, I could change that, or I could make it even more. So if I bring this all the way to like 4, okay, now you can see that it's too much. Okay, that's way too much. It almost looks like a bad photo. So I bring it down, and I keep it, literally around 1.4. There we go.
It did really punch up the red some.
Yeah, it did.
The more intense part there, like below center.
Yeah. And let's go back to our histogram and do a color correction to do that again, make it even more.
Lewis, no. Pillars of Creation are in Messier 16, Eagle Nebula, which is way off to the south of here.
Yeah, we'll have to do that again in the summertime. Hi there, Lewis Todd. Nice to see you. All right.
Izabela, that's a good point. We have talked before looking at the highlighted areas there on the Cygnus wall, and also when we see the Pelican over to the right. We wondered where the light source is for those highlighted parts, and it's actually behind that dark nebula that we can't see it. But the star that's lighting up the brightest parts of North America and the Pelican are actually behind those clouds.
Yeah, but that doesn't mean it's a red star lighting these up, because that's not what you're seeing here. This is hydrogen emission, and it's going through all of this area, but you're only seeing it to this point because there's also dark nebula up here that's obscuring some of that. And so you're going to see the edges where it goes over the edge and then down some. You'll see it, but then you've got dark nebula that's also in here as well. It's a very complex thing. And this cloud right here, you can see how filamentary it gets over here. This is sitting way in front of that way in front of that emission nebula. So this is a gigantic dark cloud that's sitting in front of this massive nebula and blocking what's behind it. So that's how that works. That's gorgeous. This is neat too. Let's get rid of the telescope. Let's move this bigger, and let's fill this up. There we go. Wow. I like it a lot. Very nice. Bullwinkle 000 says North American Nebula NGC 7000 discovered by none other than Sir William Herschel in 1786. Thank you for that. Very nice.
Herschel was a busy guy.
Yeah, I know. JSCO77, how's it going? I want to thank Bullwinkle and Cosmic Ray for their diligent efforts in telling all of you what the objects are. That's really kind to you guys. Saves me the trouble sometimes, but I like to read what you say too. Very good. All right. We're going to go to 15, and then we're going to go and move over and do the same thing. We're going to go over quite a bit, though. We're going to catch far to the right of the Pelican as well.
Yeah. When you see the very, very right edge of the Pelican's head up at the top right, you see a red highlight there.
Yeah.
And it was, it kind of threw me when we were looking at this. I forget, it was earlier this year or last year.
Yeah.
When we first talked about this, that you would think, you'd think, to me it looks like the light is coming from the right, even of the Pelican, but it's not. Actually, all that highlighting you see, like on the back of the Pelican's head and the Cygnus wall and all, I believe is coming from a bright star hidden by the dark nebulosity.
I'm not sure, but we'll see.
I thought we talked about that.
Maybe. All right, we got 15 frames here, so let me pause this now. Save it. North American Nebula 1. All right. And put this out there as well. North American Nebula 1, and it's saved as that, and now we will save exactly as seen. All right. And now we will come out of this, go back into our night vision mode right here, and move over to do the next suite of photos. Okay, and now the first thing we're going to do is bring back the telescope. Bring that back. There we go. All right, so there it is, and now we'll move over. We're going to head to the west. And we're going to come all the way over till the Pelican here is almost in the center, maybe a little beyond, so we can catch what's behind it. Okay. And then we go a little north. Another thing I'm going to adjust when I get out there is the camera is just a little bit on a crooked angle. See, the vertical should be totally vertical. It's not. Okay. I'm going to move this up a little. Went too far. There we go. Okay. That's good. All right. This will be a nice composite that we can put together. So this is just the Pelican Nebula we're looking at the moment. All right. There it is, Pelican Nebula. And we can take that out for now. I'll put it back in just a minute. I will do 30 seconds on this. And watch this develop. Spock, it's like film. Film, Captain? Yes. A 20th century medium by which they took pictures. I see. Not very efficient. No, not much in the 20th century was. Alright. And we'll clear this now. You get a beautiful illumination. You can see separation there, huh? That's because the gain is helping us see that. Oops, I gotta clear this. I might have missed that one. Okay, that's fine. It's okay, because we were not quite stabilized over here. Now we are, so we can do this. It's good. All right. Ah, yeah, look at that. That's the Pelican. Look at the back of the Pelican, Daryl. It looks like there's so much more detail back here that we just haven't seen before.
Uh-huh. Is that from the gain? Increasing the gain?
Mm-hmm. It is. We can see more convolutions in the dark dust than we can when it's at lower gain.
Yeah.
So this makes for a better picture. But speaking of better picture, why don't we show the picture? That's better.
Got a very red thing there going on over on the right.
Right there?
Yep.
That might be a nebula. An object. Yes, it is. There's a star that's doing some kind of ionizing of that hydrogen gas out there. So you guys see the pelican? This is the back of its head. This is the long bill. This is the eye of the pelican. And this is the wings, and this is the body. And that's the fish that it's eating in its mouth. No, I don't know. Wow.
Now, when you see the pelican like that, as I was saying earlier, I mean, the light at the back of its head, it looks like the light is coming from the upper right somewhere, and actually it's not. So that's like what we see as the back of the pelican's head is actually like the edge of a cloud wall.
Yeah, and if you notice,
say sort of like when we see the big wall at the horse head.
Yeah, and if you notice, one of the things that is really interesting is that this red here, something again we don't see normally, it continues all the way down here. Right here, see, it continues all the way from here all the way down. All the way down. See that? So the source can be inside here somewhere. And there's enough dark nebula between us and there to kind of mute any of that might be happening.
Yeah.
Hedrick says it looks like a pterodactyl, and it does, I guess, look like a pterodactyl. Go ahead.
I guess my point was where, I mean, if that was really shaped like the pelican's head, that light part would be curving away from us, and it's coming toward us.
Really fantastic. Okay, we'll call this North America 2, North American Nebula 2, even though we aren't there yet in terms of having it done. We're not done with it. Okay.
I mean, if you do wind up making a mosaic of this in the left side of the North America, that if it is a common light source lighting up the Cygnus wall and the back of the pelican's head here, the light source is to the left of here and it's to the right of the Cygnus wall, somewhere in between them.
Right in the middle of the mosaic, somewhere out in this dark nebula.
Yeah.
It takes some imagination and 3D perception, to really understand what's going on in a nebula like this, to actually imagine it or think of it three-dimensionally and come up with a model in your head.
Yeah.
You gotta have a good understanding of 3D spaces. Hedrick says, any sun predictions? I know that we had that large spot, Hedrick, and with the amateur radio that you're into, I wasn't sure if it affected any of your transmission capabilities in the amateur radio arena.
There is something big on the far side of the sun right now. It caused such a disturbance. They could detect it on this side of the sun, and it's on its way coming back around toward us.
Well, there was a big sunspot group that was pretty active.
Yeah.
Now, sunspots can last more than one solar rotation.
Yeah.
They can get bigger, they can get smaller, they can come and go in as little as a few days, and last for as many as a number of weeks. So, I think we have to, consider that's a possibility.
Well, yes, it was here fairly recently. I mean, it was quite busy on the sun and getting lots of flares and stuff, and it quieted down, and it looks like it may be coming back around for round 2 or 3. Longer term, Hedrick, we're still headed towards solar maximum. We haven't seen maximum yet. Mm-hmm. So things could really heat up quite a bit.
No pun intended.
Or maybe a little bit.
Get out there. Yeah. Izabela says, so this is why my brain is off these last few days. Yeah. People are affected by the sun and the radiation and the changes in magnetic field. So I understand that there's a possibility that you could feel off due to solar activity. There's no real science to show it, but it's possible. Cosmic Ray says, sun smiley face. Oh, that's cool. Thank you for putting that up. Check out Cosmic Ray's post there, guys.
Yeah. I saw that posted on Reddit this morning, and they called it sunspots, which they weren't. I've gotten to the point where I'm tired of correcting people on Reddit because it just makes them mad, so I just let it go.
Yeah, don't bother. People are at various levels of understanding, and so, if they don't understand, then they don't want to be corrected publicly, so it's okay.
Yeah, well, I'm a bit of a grammar Nazi. Some guy I did correct today, he used the word entomology when he meant etymology. I had to straighten him out. I couldn't let that one go.
Well,
insects instead of word study,
You ain't got no good English, right?
Who, me?
Yeah, you ain't got no good English.
I suppose.
You get the joke, don't you?
Yeah, I get it.
Okay.
But I mean, and per what Izabela was saying, that Anton Petrov guy on YouTube, he remarked on what I said a few days ago when they detected effects here on Earth from that huge gamma ray burst over 2 billion light years away.
Yeah, we mentioned that in Sky Tour Radio, remember?
Yeah. And so heck, if gamma ray burst 2 billion light years away could trigger effects here on Earth, I'm sure the sun could make Izabela feel like she's off.
Well, I think that's true. All right, we saved it, and it's up there now, heading up there now, so we could do a mosaic of this one. And I will now.
I look forward to seeing that.
Yeah, we'll see the whole picture. And now we could get rid of this. Come back here and go to our 1 second shot. And go jump into our night vision sequence. Okay. All right, so now let's go back and check out where to go next. Robin, your work is cut out for you if you're still listening. We've done a lot of objects in the last 2 days.
I mean, if a gamma ray burst, I think it was 2.4 billion light years away, billion.
Yeah.
it had ground effects here and it had atmospheric effects here.
Wow.
Could do that
Yeah.
here on Earth from that far away. I would hate to have been anywhere in the galactic neighborhood of that gamma ray burst. Probably sterilized quite a bit of space in its area.
I wonder how long it would take for the bad radiation to attenuate away. Good, Robin. Glad you're still listening. Your work's cut out for you, though, as I said. Got lots more going on. All right, let's do this. Let's come in here, get that going, and then go to our stellarium. And we're going to go do the Cocoon Nebula at the higher gain. We haven't done the Cocoon at this high gain before. You asked about the Cocoon the other day.
Did I?
Do you remember? Yes, you did. You said the Cocoon is still up, and I said, yes, it is.
But we didn't do it.
No, because you were asking me before we actually had a let me get out of this here a minute. Oh. We actually had we weren't doing a stream at the time.
Okay.
Yeah.
I have a hard time remembering what I had for dinner.
Okay.
You say so.
Right. It's all right. All right, so now we're going to head north on this one now. Just grab this. We'll see the Cocoon come in. Here it is, coming in from the right up there. Yes. Now the Cocoon is really, really interesting. It's trailing a long filament of dark nebula behind it. And we're going to try to peer into that dark nebula tonight and see what's there. You can see where the stars are being hidden behind it right off the bat. But let's move over to the west and put it over here.
Oh, I sent you an A-pod of the Cocoon just in the last day, I think. Yeah.
Yeah.
And it looked really tricked.
Okay.
I recognize it now.
Yeah. All right, so we're going to go there and go north. Drop it down a little bit. There we go.
And that reminds me, did you see that article I sent you about the world's largest camera?
Oh, I didn't read it yet.
Oh, you'll have to look at that when you get it. I would, if that thing to me, okay, the lens, it uses lenses, not mirrors. Its aperture is 5 feet, 60 inches, or 1.5 some odd meters. That I would, and it's a wide field too, 3.5 degree field. I would think you'd have to call that the new record for a refractor telescope.
I think
they call it a camera, not a telescope. But you look at this thing, and I mean, it sure looks like a great big refractor lens to me.
Yeah. Okay, we're gonna go through a focusing step here. Over here.
That's it. Thank you, Izabela. 3,200 megapixel camera.
Wow, that's a big camera.
With a lens 5 feet across.
Mm. All right, so. Uh-oh. Does that mean? Why did it do that? I wonder. Oh, I'm not stacking. Oh, I see. It's a 30-second exposure. Okay, we got to go back to the 1 second right now so we can do our 1 second. Why does it go to 4 when I say this? I shouldn't do that. Okay, now we'll be here at our wonderful place to be, and now I can just get our focus ready. All right. So our focus is out just a little bit, and we're going to bring our focus into the perfect range. And we're going to do our focus adjustment. We're going to scan inward. You can see that it picks the stars to focus, and it gets their data, evaluates the size of the image, and then continues to focus. It'll go in and back out and form a parabola, and at the center it'll put a line through it, the line of best fit, and then it'll draw a line for the best focus position, and then the telescope will be taken to that position at the conclusion.
That's what I was wondering earlier, since we've been back online, that I hadn't seen you run a focus, and I know it's cooling off a lot down there in the desert at night now. If focus adjustment may not become an issue again.
Yeah, well, what I mentioned earlier, that I did a focus run earlier tonight. Okay, so now we're in perfect focus. This will be beautiful. So now what I'll do is I'll come out of this now. Now you can look at that. Nice detail. Let's go into a 30-second shot at 400 gain. And, no, I don't need to worry about that right now. Thank you very much. And away we go. And let's jump into the live stack. I think those of you remember what live stacking is. We're actually taking an image, taking the second one, aligning it, and then making an image sandwich, doing the same thing over and over. So that the data in the images, the data comes out. Dark nebula that's hidden will be brought to the top and have a peak in the data. So there'll be lots of data built up upon data, and all the dark stuff is full of just noise. Oh my, look at that. The dark stuff full of noise will just be averaged out. Look at this. Okay, let's do this. Let's try to bring up some more data here. Let's color correct. There we go. Nice.
I think I do remember this. Talking about this now, that the dark area, first real dark area right is center. Kind of reminds me of a fish's tail.
Ah, okay. Look at that. That's really pretty, I guess, I have to say. Wow. Well, this is after 2 stacked. And this, what's interesting is, this is a region that's full of hydrogen gas, and it's also full of dark dust. And so this nebula here is actually a hybrid. You see it has a blue fringe, right? And that's because the hydrogen is much more dominant over a subtle reflection nebula. But you can see lots of blue, and we're going to see more of that coming out as this progresses. And you can see blue around this star. So there is a lot of scattering of the blue light going on. But then the star that was born in here is actually really ionizing the hydrogen gas nearby, causing it to glow red as well. And that happened inside this dark cloud. So this nebula was never there. Once the star was born inside this dark nebula, remember what I said, the dark nebulae are where it's at. This is where stars form, this is where planets form, that's where life happens. Okay, the beginnings of life happens anyway. Well, the star is ionizing that hydrogen gas and making it like a lonely little lighthouse in the dark nebula. It's amazing how this stuff works. Beautiful. Look at that though, huh? That's really pretty. You could be mistaken for thinking this has been just this orange thing's been traveling through, leaving a litter of dust behind it. In all likelihood, that filamentary cloud was there before, and then there's a star that formed in it, causing what you see here. It's very, very, very clear how that happens.
That apod of the cocoon came out a day or two ago. It is a very deep exposure.
Okay.
All the dark stuff you see is illuminated.
Mm-hmm.
That is so trippy looking.
Yeah, it is.
And as I sometimes see in images like these, I mean, there's our obvious dark nebulosity, but down at the lower left, I see narrow dark bands meandering around. Are they real, or are those artifacts of the imaging somehow? I've always wondered.
I don't think they're artifacts of the imaging, because this right here, you see this thing right here? It looks like a dark line.
Yes, that's the sort of thing I'm talking about.
And then it comes down here if you follow it. So I imagine this is actually a tendril of gas, or I'm sorry, of dust that's in here. There's gas in there for sure. But see what's happening now, guys? Look at, now the blue is starting to come out. You can actually see the blue haze around this nebula as well. It's fascinating too, because when you look at this, you literally see the limit to the ionization. This isn't just a big spherical ball of hydrogen gas and then there's no hydrogen elsewhere. There's plenty of hydrogen elsewhere. But this is the limit right here to how much this star can ionize hydrogen gas.
As the image builds, as the images stack, you can start to see color in some of the dark nebulosity already.
Yeah,
you know,
like right
we'll sometimes say it looks brown instead of black, or even a reddish cast to it.
Yeah, this area right here is going to take on a life of its own, as you'll see. You're going to start to see some tendrils in here. I see one forming right there. Hedrick had a question, and his question was, tell us the colors of the stars again. Could you tell us? We have what's called spectral classes, and the spectral classes are the different colors based on temperature, with blue hot being the hottest and red being the coolest, red hot being the coolest. So with the brightest, hottest stars, they're going to be type O, which are the O-type stars. And then it goes down to the B stars, A, F, G, K, and M. Now, if you want to remember it, you could remember it by saying, "Oh, be a fine girl, kiss me," or "Oh, be a fine guy, kiss me." Either way, it's a G. So if you remember that, you'll remember the spectral classes, right? "Oh, be a fine girl, kiss me." Why would a girl who doesn't kiss you not be fine? I don't get it. I mean, I know plenty of girls that won't kiss me that are fine. So I never understood it, but it was something that we were taught when I was getting my astronomy degree as a bit of comedy. It wasn't even taken seriously at the time. And I haven't used it in decades, because you get so well into it that you know what you're talking about.
You know, Russell looked that up, Hertzsprung-Russell diagram. That demonstrates the different spectral classes and the star sizes and how the whole thing relates.
I'm teaching the Hertzsprung-Russell diagram next weekend out in the desert. I'm going to be talking about it. I'm talking not only about that, but about luminosity classes as well. You know, because you talk about stars that have brightness. Well, the intrinsic brightness of a star, I feel like a halo over my head, that this red is illuminating me from this thing. You know, you talk about how it works, and basically the luminosity class is just basically a reflection of what the evolutionary state of the star is. Right? It's a Roman numeral V, 5, Roman numeral 5 for the V. That's a star like the sun. It's normal fusion processes, hydrogen becoming helium isotopes. And And you can have that in all the stars, O, B, A, F, G, K, M. Even the hottest and bluest stars start off as fusion generators making hydrogen into helium, but they only last a few million years at that level before they burn through it and start to swell and become red giants. What's an example of that? Betelgeuse. Betelgeuse very likely was an O-type star, and then it ran out of its hydrogen, and then over a few 10,000 years it began to swell into a red giant. Now if you put that red giant where the sun is, it would go almost to the orbit of Jupiter in radius. So now double it, because that's the diameter. That is massive. Massive. So when you think that it took us several years to get a probe out to Jupiter, well, in the same way, it would take you double that to cross the surface of Betelgeuse with a spacecraft. Izabela says, the more I watch STLS, the more my appreciation of dark nebula grows. Yeah, they seem to be very important objects, if not the most important. And you're absolutely right, Izabela. Absolutely right. Cosmic Ray mentions, which I think you're probably replying to, that camera, the LSST, will be put on an 8.4 meter scope in Chile.
So you couldn't call it a refractor.
I guess not.
Well, they have a picture of it. You know, it doesn't look like a conventional refractor. It's got a great big lens on the front, but it's boxy behind it. Not a big long tube as you'd think of a classic refractor.
Is it a folded optical path telescope?
No, it's a wide field.
All right.
It's got like a 3.5 degree field to it. It's got a huge, I don't remember. I'd have to go find the article again. I don't remember if it's really CCDs or not, but electronic arrays to instead of film.
It might be just a bunch of very, very high-end CMOS.
Or that, yes.
As you can see, I'm playing with the data here, and you can see three-dimensionality here in this now. And we're at 21 stacked. You see that? Now, if we actually just let it do its thing, okay, it brings it to that. But if we bring this to the left, we bring this peak out, you can see that it looks a little bit more 3D, and intersect more of the data, and then punch this into this a little bit more. There we go. That's incredible.
I mean, if you're a 2 by 1.5 degree field, imagine a 3.5 degree field with an aperture of 60 inches.
Yeah, but it's a wide field, right?
Yeah.
So the F ratio, the F setting is gonna be low. It's gonna be F4, F2,
something like that.
Okay, we're at 24. We're gonna stop at 25 and bring the detail. This is a beautiful image.
It is.
All right,
I see it changing constantly.
Yeah, it looks like it is.
Like it's a slow flicker or something.
Oh, I don't see a slow flicker.
Okay, it's quit now.
All right.
Yes, Izabela.
Well, what'd she say? What are you answering yes to?
She says the dark cloud on the right could be the closer to us. There are less stars visible than on the left.
Yeah. Hey there, Hunter. All right. Okay, my son just got home. All right. Yeah, this is showing more detail in this dark cloud than we have ever seen before. There's more detail here than we've ever seen. This cloud is definitely brown. You can clearly see that. I think we're going to be able to pull a lot of detail out of this. You know?
Mm-hmm.
Oh, yeah. Without a doubt. Without a doubt. Indeed. Okay. You see there's tendrils going up. We didn't really see those before. There's another cloud down here, which we knew was here, but it connects to this. It's a very complicated region. And there's more coming out down here. Wow. Nice. Okay. Alright, Cocoon Nebula. And we're at 28. I guess we'll just let it go because we want to get rid of most of the noise. And you need long exposures to get rid of the noise. Longer stacks. So we'll do one more 30-second shot after this. Make it an even 30.
Cosmic ray, they say the party hadn't started until after you've thrown up the first time after you eat peyote. I could tell a peyote story, but I don't think I should. I never did.
Pause. Okay. There's a Cocoon Nebula. We're going to save it at 30 exposures. Alright. And we'll save it exactly as seen. Alright. There we go. We'll clear it next time we come in. There's a lot of three-dimensionality in this. We can actually see quite well. Let's get the telescope back. There we go. Alright. And then now let's go into the next phase. We'll go see the next object. We're just going to keep riding up the Cygnus Milky Way to the logical point where we have to stop. Alright, let's get rid of the stack here now. Okay. Let's go to our all sky first and do an acquisition, and hopefully there won't be any interference. Okay. Apparently I stopped the exposure by accident, sorry. I saw clouds coming down, so I was trying to sneak in a stream before they came down from the north. There's no rain in them, but you know. Oh, looks like it didn't. Okay, looks like the camera is not. Oh yeah, it says it's there. So what happened? Oh, maybe I turned. Oh, there it is. Okay, there we go. The clouds have not affected us. We're good. All right. So I like having our all sky as a backdrop. Okay, this is good. Let's go up now and find the next item. What are we going to do here? Well, we did Elephant's Trunk the other night, but what else can we do that we haven't done yet? Are there some galaxies up here that we wanted to see? Oh, wait a minute. This is Cepheus.
Sure is.
I want to go why don't we do this? Let's do, this is one that didn't show well for us when we tried to do it last time. Let's see if we can do it now. The Cosmic Bat. Otherwise known as Sharpless 2, 129. Okay. There's our waypoint star. We're at 47% zoomed. I'll bring us down to autofill. There we go. The telescope is pretty high in the sky, so this might be pretty good. Okay. Okay. We went to Alderamin. There we are. Okay, and now up we go.
Mark, excuse me a moment, please.
Sure thing.
Be right back.
All right. All right. So this is the Cosmic Bat, huh? We have seen this before, but it wasn't very exciting. Let's go find out if it could be made any more exciting. Yeah, there's something here. Let's get our system in shape and let's get it going. Okay, we're cranking, we're stabilizing our guide. Let's go. See the Cosmic Bat. And there's the cocoon. That's going to be stunning. Oh my gosh, I can't wait to process that. So tell me, guys, what do you think? Is this worth the trip or what? We travel light years every single night. You don't have to leave the comfort of your house. Ah, look at that. Wow. Definitely shows better tonight, I can tell you that. Okay, Cosmic Bat. Cosmic Bat it is. Okay, we'll take that out for now because you've seen it. Wow. Thank you, Bonnie. Bonnie says, love it so much. That's good. Hedrick says, how many planets do you think we have in our galaxy? That's a good question, Hedrick. But keep in mind that on average, Every star has at least one planet on average when you average it all out. Some stars have more than one planet, and some stars have none. But when you average it out, every star you see in this image, on average, will have a planet. At least one. And there's about 100 billion stars in our galaxy. In the Andromeda Galaxy, there's about 1 trillion stars. Well, there's 1,000 billion.
They
Welcome
usually
back.
say 400 billion in the Milky Way now.
Well, remember the agreed upon was 100 billion, and then I've seen it go as high as 400 billion, and I've seen it be Earth-like planets measured at 10% of the number of stars in the galaxy. So anywhere from 10 billion other Earths out there to 40 billion other Earths just in our galaxy, and there's 2 trillion other galaxies. So it literally boggles the mind. The human animal cannot comprehend what 1,000 of anything is. Okay, you can't really imagine 1,000 things. So imagine trying to be asked to imagine 5,400 things, or 1,000,000 things, or a billion things. You get to those high numbers, and you just say it's a lot, and you can't process it further. In my book, The Populated Universe, I talk about the problem with the numbers. That's chapter 1, and it talks about how we view the universe, and we quickly go out past our numerical concept limits when we talk about the universe. If you make a scale model of the universe, shrink it down, the universe, make it a scale model. To talk about the Earth-Moon distance, if you put the Earth-Moon distance at just a few inches, the Earth-Moon distance, okay, from 250,000 miles to the Earth-Moon distance being just like 3 inches across, the universe is still astronomically large, and you need astronomically large numbers to describe it. So take our solar system and put it on a coffee saucer, okay, about that big, okay, Sun in the middle and Pluto at the extent, because Pluto is a planet, okay, and if you do that, the nearest star to us with a solar system the size of a saucer, the nearest star is in Washington, D.C., as seen from Connecticut. Okay, that's huge. The nearest star is over 200 miles away, 250 miles away. So, and that's the nearest one. And you have stars that are closer to each other, farther from each other. So, you can make models, but you always go into astronomical numbers to describe it when you make a model of the universe. Just a lot of fun. This is the cosmic bat, Daryl.
Yeah. Did you say we hadn't looked at this before? It looks kind of familiar.
I said we did look at it, but it didn't really show well.
Oh.
It didn't show well to us.
Well, it is tonight.
Looks better, yeah. In fact, let's go over and add a little punch. See what we're missing. Look at that. You see what I just did? I punched up the come here, you. I punched it up a little bit more, so look at this. It's just looking great.
What did you do? I'm sorry, I was looking away for a moment.
I played with the histogram on this right here. See, if you punch that up, that histogram punches it up, and you see a lot more stuff. It actually starts to look like the California Nebula.
Okay.
And then, if we were to come over here and take this mid-level and punch it up a little bit, we get even more. And then we can bring this dark down to add some contrast to everything. Look at that. Look how many stars are in this. Oh my gosh, look at that. Isn't that pretty, guys? JSCO77 says, that looks so much better. It does. The October 2023 solar eclipse Yeah, we're planning on an expedition to go see it. No matter where I am, I will be heading to go on that expedition, I'm sure.
October 23 solar eclipse. Where are you located, Hedrick? The big eclipse they're talking about here is April of 2024.
Yeah, that's the one we're going to go up to New York State.
The 24.
He's in Southern Oregon.
I'm going to have to look this up.
Well, while you're looking it up, check this out right here. There's a beautiful reflection nebula right here. See that right there? The reflection nebula. You can see it right there. Right there, look at that. It's just surrounding these stars right there. Wow, that's pretty.
Oh, okay. I have heard. This is an annular eclipse. October 14th, 2023. It's going to cut across the northwest to the southwest down to Texas.
Yep.
That's an annular eclipse. Whoops. Annular.
Yeah. Wow, and this is really pretty.
Yeah, that's it's going to hit the northwest, Oregon, I guess, and trail across the American Southwest and wind up going down through Texas. The April 2024 is a total solar eclipse. That's the big one.
That's
is that
the
the
one
one you said? Yeah.
Yeah, that's the one we're going to go on to the expedition.
That's going to be a madhouse up there.
I mean, it could be anywhere along the line, and I think we're probably we might actually, instead of going to New York, we might go to Pennsylvania for that one and see it from Pennsylvania.
I know Bill would talked about it. It's going to go way up in northern New York, Rochester. I forget.
Yeah, it's going to head up that way.
Yeah, but especially the whole eastern U.S. is so populated that it's going to be a madhouse anywhere along the path of totality.
I prefer to focus on the event and say, I will find a way to look up somewhere along the line. It doesn't matter where you stop, because if you're in that range of totality, I want to see eclipse bands, which have been known to make people sick to their stomachs because it throws off things on them. Eclipse bands are like basically interference patterns when the moon crosses over the sun as seen from the Earth, and these eclipse bands will come in waves. You'll see waves of dark bands alternating with brighter bands coming through and go shoo, 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 shoo. And
you see them down on the ground, don't you?
Yeah, you can see them against like a white building, a wall or something like that. You can see them. Yeah. And you can miss them entirely if you're not careful. Wow.
I know I looked for such effects when I saw the solar eclipse in 2017, and I didn't see such. And there weren't any trees around to look for, the little shadow.
Yeah, eclipses.
How they say when the eclipse shines through tree leaves and stuff, you'll see a bunch of little crescents and things.
Yep. I saw that.
I've seen that during partial eclipses. I'm going to post a link to the article for the October 2023 annular eclipse.
Okay. And I'm done here with the Cosmic Bat. I saved it, and then I saved it out there. I'm gonna save it one more time. There we go. All right. Beautiful.
I saw the when was that? May 10th, 1994. I want to say the annular eclipse that happened in. I saw it from just north of El Paso, Texas. It's a ring-shaped eclipse. The moon was far away in its orbit, and the sun was relatively close. So what we saw was a ring of sunlight all the way around the body of the moon. It looked like a big hoop of fire. It was really cool. It's considered a special case of a partial eclipse. Oh, so close to a total, but not quite.
Wow.
It was really cool looking, and I shot a whole roll of film taking pictures of it.
All right.
But I had to wait till 2017 to see the total solar eclipse. Can you rephrase your question, Hedrick? How far percent does the moon go? You mean like what percent coverage? It'll depend. Everyone is different. The one I saw back in '94, it covered like 95 or 96% of the sun. So you just saw a little skinny ring of sunlight. 20% more than what?
I'm just looking for our next object. Well, this never fails to impress. We've done that one just the other night. I want to try a different one. We did the Cassiopeia, Gamma Cassiopeia, Navi. Did that one. Oh. Is this the cave? No, this is NGC 7562 or 7822. I think it's this one. Oh yeah, this is a gorgeous nebula. We gotta check that out too. All right, we're going there. We going bye bye. Remember that from the song Convoy? Who remembers that?
I didn't know you had it in you.
Convoy?
I didn't. Yeah, are you a redneck at heart or what?
No, I had a CB. Actually, a CB saved my bacon one time.
Well, I had a CB too back in the day.
Citizens Band Radio. And they were the coolest things. And I actually got in an accident, and there was no one around. And I got on the CB on Channel 9, and I ended up calling for help, and I had the police within 5 minutes.
Huh.
It was really cool. Yeah, on the radio. Then it took some while to get there.
I was driving in a VW Beetle from Missouri to Colorado, and I lost fourth gear in the VW about a fourth of the way across Kansas. So I drove 3/4 of the way across Kansas and halfway across Colorado, more than halfway across Colorado. In third gear, doing 45 miles an hour, and that CB radio kept me from going crazy.
I'll bet so.
We just got on the radio and talked to truckers all night long. It was funny.
Yeah. Breaker 19 for this VW Pokey. Yep, VW Pokey here. Alright, so we should be seeing the... There it is, right there at the center of this nebula. We're going to just drop down a little bit more. There we go. One more little jog. Move it a little bit west. Wait for it to stabilize. Alright, that's better. Okay. So this is full of nebulous detail, and we're gonna go find it all. And this is known as NGC 7822. Alright.
AKA.
It's just NGC 7822. It's not the cave.
The number rings a bell. I'm sure I'll recognize it once you get the stacking going.
Yep. Alright, so that's the Cosmic Bat. I love that. That came out really nice.
We hardly even talked
Very
about
happy
that.
with
I like the row of
What's
3
that?
stars up there at the top left.
Oh yeah, that's cool. I gotta clear it though, because we got the other one coming in. Ah, there we go. See the pillars? Oh yeah, this is just beautiful. It's this one. This one has a quality, guys, that makes it look 3D in a sense. We can't really read into the 3D nature of it, but we can see it probably is 3D when we look at this. Absolutely stunning.
I think I recognize this now. Can you zoom in yet, or you need to let the exposures build a bit?
I have to let it build just a little bit.
Yeah, I think I remember that one. There's a pillar down there,
Remember this
a little.
pillar right here?
Yes, exactly.
Yeah.
Remember, right there's a skinnier pillar right next to it. Is that the one?
There is. Yeah,
Okay.
That's right there. Yeah.
Yeah, I remember.
And the cave has the Herbig Harrow objects down the bottom. Remember that?
Hmm.
And I do not believe that this is nice. Look at that beautiful nebula with this beautiful ionized front on it. More gases being ionized in the front than inside. Wow, look at that. Man. Let's do a color correction on this. Okay. And let's pull this out a little bit. Let's see what's actually in here. Alright, that's called a push. So we can see what else is in here waiting for us that we'll discover in a little while. Gorgeous. And let's just bring it down now and wait. Really, really pretty. Robin she asked minutes ago, I forgot to answer. Did we do the Soul Nebula? Yes, we did. Last stream, I think we did this, the heart and the soul. Because we have heart and soul, man. Look at this. Wow.
Yeah, Uberku, that eclipse, it's the big, long anticipated total solar eclipse. It's going to cross the border from Mexico into southern Texas, and then it's going to make its way northeast across the middle, the Midwest, and the east and northeast United States. And it's going to top out in the U.S. up around Rochester, New York, if I remember right. Bill made some noise about me trying to go see it. The time of day is going to change as it goes east, though. It's going to be rather late in the day, and actually it's about one of its last points of contact on land is up in northern Nova Scotia, not far from where Amanda lives.
That's right.
And it's going to be about sunset by the time it hits there.
Okay, we got 8 stacked. Let's check out what we got here.
There's the big pillar and the little pillar. I remember now, yeah.
Yeah, the big one, this little guy, this little spire right here. And a third little tendril right here. Look at this. Let's zoom in.
And I can guarantee you it's going to be a madhouse almost everywhere along the path to totality. I got lucky when I saw the one in 2017. I was headed north of Cheyenne, Wyoming, and traffic came to a dead stop on the interstate about 2 or 2.5 hours of where I was intending to go. I mean, it got so bad, and this was at 6 a.m. The traffic came to a dead stop, and it was a total log jam for all day. But I had a backup site in plan, and when it came to a stop, I was right at the turnoff for the backup site on another interstate. And I drove like the devil to get to it. I wound up north of Scottsbluff, Nebraska, kind of out in the middle of nowhere. There was still a lot of people, but it was nothing like it would have been if I had stayed in Wyoming. And it was excellent. It's the number one astronomical event I ever saw, and I waited all my life to see it. And the one downside of the eclipse in April, and this goes for most eclipses too, is as a general thing, the farther east you go, the worse the weather prospects are.
Yeah. Hey there, Taryn Marie. Nice to see you. What, are you eating Tic Tacs over there like candy or what?
No, sir.
Okay.
Getting ready to administer some medication.
Okay.
Sorry, I should have muted myself.
So here you can see it now is we've got 13 stacked. Look at how beautiful these little spires look. Look at this. Now, I've explained how these happen, but you see this young cluster that powers this. Okay, this has got a young cluster right here, and you'll notice that the spires seem to be pointing at it. That's interesting, and it's true. Notice this spire pointing at it. Okay, notice this material ionized by this most likely. All right, and then this vertical line here. This is again all material that is being affected by this young hot cluster with very, very powerful stellar winds. And those stellar winds erode the lower density material. And right at the top of this, it hasn't been eroded because way up here in the top is a higher density concentration of dark nebula that is actually protecting the leeward side behind it. So that's why this hasn't evaporated and been eroded yet. Same thing with this one. Same thing with the other ones that we see. Here you go. You're looking at this one. You see the same thing. This part hasn't been eroded, or hasn't been eroded at all, and it's safe down here. It's almost like the leeward side. Same thing here. And again, they're all pointing back at this cluster. So that cluster is likely even though we're looking at it in only 2 dimensions and not looking at the full 3, that cluster is likely the reason that this nebula looks the way it does. The cluster is actually in the process of hollowing out this entire central region, and behind this dark nebula, okay, is the rest of the nebula you can't see. This black nebula, this dark nebula, is actually in our foreground, and this cluster is behind it most likely, and doing its dirty work, and this nebula is just sitting in front of it. That is really a very interesting location. That's why I like NGC 7822, because it has all these interesting things going for it.
And the formation of those, they're exactly like the pillars of creation in the Eagle Nebula. Same process is going on.
Yeah, which I was just talking about, the erosion process from the starlight. Remember, these stars have very, very strong stellar winds. And what are the stellar winds composed of? They're composed of particles. Particles that are, for instance, hydrogen nuclei, protons zipping away from the stars at high speed. And they're also composed of electrons, again, particles. So they're actual particles heading out into space. And when they strike other atoms, they would tend to push them because they have momentum, they have speed coming from this cluster. And even though a hydrogen nucleus, a proton, is very light, when it hits something heavier or more massive, it's still going to impart some type of motion. So long term, it's going to cause the lower density material to stream away, and the higher density material will actually be able to withstand it. And that's just what we see. You know,
Alice.
And we look
Alice.
at Daryl.
I'm sorry.
Yeah, okay. As Daryl had mentioned about the pillars of creation, they're formed the same way that these pillars were formed. But go ahead about Alice.
Oh well, Alice Cooper said, "Why didn't it blow away like the dust in the wind?" It is in the process of doing so. Actually, that's what's shaping those pillars now.
Right. Yeah. By the way, hello, Alice. Good to see you. And Judy McClellan, nice to see you as well. Well, you missed pretty much the whole stream, but don't worry about it, because we always like having you, no matter when you can reach us and when you get here. That's okay. Just beautiful. Let's see if we can pull out some more detail.
Why
Yeah, look
doesn't
at that.
this have a name?
It may have a colloquial name that we don't know about.
Well, that's what I'm looking for. It's Sharpless 171.
Yeah.
The young
Or
cluster of
NGC.
stars is named Berkeley 59.
That's this.
I would
right
just
here,
think something as I would think something as cool as this would have a name to it.
Yeah. Like Northern Eagle. Here, let's take that out of there. We're going to do one more image after this. One more stacked, I should say. And then I have to get up early tomorrow, so I'm going to have to terminate the stream earlier. But don't worry, folks. We've been averaging every other day. And the more we do that, the more we see objects coming up that we want to see. When Auriga comes up, there's a lot of stuff in the constellation Auriga to see. Oh, yeah. There it is. There's our 25th. So again, this is NGC 7822. We'll pause it there. If I had time, I'd go to 40 frames on this one. And we'll save it. And save it exactly as seen. Now let's try something really quick here before I get out of this. Let's push this even more. You'll see a lot of noise. And now let's zoom out. Okay, that's a little too far. Let's bring it back a bit. Okay.
One of the stars is called oh darn it, I lost it. There it is. BD plus 66 1673. It's an eclipsing binary system. It's an O5V star. Exhibits a surface temperature nearly 45,000 K and a luminosity about 100,000 times of that of the sun. That's one of the primary sources. Illuminated the nebula. I'm sorry.
BD plus 66 and change.
Yes.
The BD stands for Bonner-Dirk-Merstring. It's a German atlas, and the plus 66 and change is actually its latitude, its declination.
Yeah. It's one of the primary sources illuminating the nebula and shaping the complexes famed pillars of creation type formations, the elephant trunks.
There you go. All right, let's return this. Actually, you know what I'll do? I'll save this again, and I'll save it exactly as seen like this. Then I will do this to kind of bring it down and save it again exactly as seen. It doesn't change the data, right? And then I will bring it down to what it was before we did any of that, and look how much more data was in there. So you do this, okay, then I'll do this one, save this one exactly as seen. Wow. Phenomenal.
Nice picture.
This is going to make a beautiful photo and a beautiful metal print on aluminum for somebody. Well, guys, I am so happy that I could spend this time with you. I'm sure Daryl is very happy to spend this with you as well. And we will come back again probably in the next day or so, day or two, and stream again because it's wonderful. And with that music, you know what that means. It's time for us to say nighty night. We say hello with it, we say goodbye with it. So I hope you guys do have a great night. Hey, I want to say hi to Curtis Horn. I see you just showed up. I apologize. Roni Hassan, thank you. Good to see you. And we will see you the next time on SkyTour Livestream. This data is going up on the database. It's probably there now. But I want to thank all of you guys for coming out, and we'll talk to you again. We'll catch you in a day or two. Good night. You can say good night, Daryl.
Good night.
There you go. All right, guys. We'll see you later.
Sorry, I was typing.
It's okay.
Good night.
Wow. Really pretty.